All right, we are going to continue to look at notes H, and we are picking up with parent functions or library of functions. You'll hear me refer to them as parent functions. The reason that we refer to them as parent functions is because variations of these functions are born from this basic one. So when you see lines or parabolas or cubic or absolute value graphs that are shifted around, they're all coming from this original parent function. Okay. These parent functions are functions that you should know off the top of your head. Some are already going to be familiar to you. Some you might have to work on learning. You might want to make flashcards for these for yourselves. But either way, you definitely want to make sure that you copy down the information that we're about to cover here and spend some time making sure that you know your parent functions. All right, the very first parent function that we have is y equals x. And this is the linear function. The graph is given for us. Notice that it goes through 0, 0. It has a slope of 1. Okay. Its domain, I'm just going to write D here for domain. Scanning that graph from left to right is negative infinity to infinity. Those are x values. Range is our y value. Scanning that graph from bottom to top, we are looking at negative infinity to infinity again. And this has symmetry to the origin. And I think for most of you, that basic linear function is going to be something that's familiar. The next function is going to be very familiar for a lot of you as well. This is y equals x squared. This is the quadratic function. Its graph is known as the parabola. It's that U shape. Okay. This domain, scanning left to right x values, again is negative infinity to infinity. Its range, bottom to top y values. We have a y value that's as low as 0. It is included in the graph, so it gets a bracket, and we are going all the way up to infinity. Remember, infinity and negative infinity always get those parentheses. And this graph has symmetry to the y-axis. Now, keep in mind that this information I'm giving you is for the parent function. When we get to moving these graphs around and transforming them, it can then impact things like domain, range, and symmetry. The shape of its graph can change a little bit as well. It can stretch, it can shrink, it move left, right, up, and down. So again, this information that we're looking at is for the parent functions. All right, next up we have this snake-shaped graph, which is y equals x cubed, and this is my cubic function. Goes through 0, 0. Like I said, it has that snake shape to it. Okay, that nice curve. Its domain, scanning those x values from left to right, is negative infinity to infinity. Range, scanning those y values from bottom to top, is also negative infinity to infinity. And our cubic function is symmetric to the origin. All right, now this next graph has a nice V shape to it. It is y equals the absolute value of x. So remember, those two vertical bars around x is absolute value of x. Now, if this is one that you're not as familiar with, a fun little easy way to remember it, value is V. The shape of this graph is V. So absolute value graph is going to have that V shape to it. Domain, scanning those x values left to right, is negative infinity to infinity. Range, scanning those y values bottom to top, we are go as low as 0. It is included in our graph, so it gets a bracket, and we're going all the way up to positive infinity. Now, the symmetry on this graph is to the y-axis. So if I fold this in half along that y-axis left to right, both sides of this graph are going to match up on one another. All right, next up, we've got 8 total parent functions. So these are numbers 5 and 6. We have y equals the square root of x. This is our square root function. Now, notice that it kind of looks like a sideways parabola, but it's only the top part of that sideways parabola. The reason we only use the top part here is so that it is a parent function. It passes that vertical line test by only using the top part. Okay? When we look at the square root function, we have a domain of 0 to infinity with a bracket around that 0. Furthest x value to the left that this graph touches is 0, and because it's included in the graph, it gets that bracket. We're going all the way to positive infinity on the right. So keep in mind that in these graphs that this is really just going all the way to the right. All right, range, same on this graph. Lowest y value we have is 0. It's included in my graph. And then it's going up to infinity. And this square root function has no symmetry. All right. Following the square root is my cube root. Makes sense in the order. Now, if you peek back at your y equals x cubed, your cubic function, notice that this looks like the cubic function, but it's on its side, cube root. Kind of like the square root looks like it's x squared, that parabola function, but it's on its side. This one is a function all on its own, so we don't have to worry about just using one half or the other. So this is our cubic function on its side, so we get y equals the cube root of x. All right, my domain, x values left to right, negative infinity to positive infinity. Range, y values bottom to top, negative infinity to positive infinity. And my cube root parent function has symmetry around the origin. I actually used that example in part 1 video as one of those graphs that had symmetry to the origin. You probably just didn't know it was a cube root graph yet. All right, we have 2 more. These last 2 probably are not as familiar to you. This next one is my reciprocal function, y equals 1 over x. If you have not seen this function before, its name should kind of make sense. Instead of being y equals x, it's y equals 1 over x, so it's the reciprocal function. Okay, now my domain here is the following. Let me draw this in for us in our graph actually before we go straight into the domain or range. So this graph actually has a vertical asymptote at x equals 0. Makes sense when you think about it because we can't have 0 on the bottom of a fraction. So when I scan this from left to right for domain, I am going from negative infinity to 0. I cannot include 0, so it gets a parenthesis. Union, pick up right on the other side of 0, and we're going to go all the way to positive infinity. Now, range works very similarly here. We have a horizontal asymptote on this graph of y equals 0. So my range when I scan from bottom to top, I go from negative infinity to 0, pick up on that other side of 0, 0 to infinity. And those zeros get parentheses because we don't actually include the 0. We've got to skip over that 0 where those asymptotes are. And this one has symmetry to the origin. I snuck this one in as an example in part 1 as well. You just probably didn't know it was called the reciprocal function yet. All right, and our very last parent function is y equals 1 over x squared. This is the reciprocal squared function. So keep in mind that when I square something, it makes it positive. So that part of our graph in the reciprocal function that was down in that third quadrant, when I square it, it is flipping up over that x-axis. Everything's positive here now. We still have those asymptotes, though. We still have that vertical asymptote at x equals 0, and we still have that horizontal asymptote at y equals 0. All right, so when I look at domain here, my domain, scanning left to right x values, is still negative infinity to 0, union 0 to infinity. My range, though, the lowest this graph goes is 0, but it's not included. It gets that parenthesis all the way up to positive infinity. And the symmetry of our reciprocal squared parent function is to the y-axis. Boom. So 8 parent functions you want to make sure you know inside and out. Make flashcards if you need to. Copy these down a couple times if you need to. Whatever you need to do to commit them to memory, because knowing what these basic shapes look like and how these basic graphs behave is going to help you so much moving on in the future of this class and the future of other math classes as well. So spend some time on these parent functions if you're not already familiar with them. All right, I'm going to pick up on part 3 in the next video.